to the idea of intervals and an important function. This is also known as a distance function, but we will call it as absolute function. But before that, I'm going to just recall the thing that is known as interval. What is an interval? Interval is a subset of real numbers, and there are types of intervals. If you have, let A and B be two real numbers, and A and B having ordering, we can assume without loss of generality that one of them is less than B. If they are not equal, then this set A, B, which includes all those real numbers which lies between A and B. And B. This is called closed interval. This is closed interval. And another type of interval that we have these brackets to denote this interval, and this interval we have set of all those real numbers which lie strictly between A and B. In the closed interval and this new interval, which is known as open interval, what is the difference? The difference here is that in closed interval, the endpoints A and B are included. They are part of this set. Whereas in this interval, open interval, the endpoints A and B are not the part of the set, as it is clear from these inequalities and are the definitions of the intervals. Sometimes we may also take endpoint A, but we will not take the endpoint B. Then this such type of an interval is known as a semi-open interval. And similarly, you might take B, but you do not take A. So these two types are semi-open intervals, and depending upon from which side it is open, you may refer that side also. So this interval, it is open from right. It includes all those real numbers, which include A also, but it doesn't include B. Similarly, this left open interval is also known as right closed, and right open is also known as left closed also. You have these elements here. You in this left open, you will not have A as a part of this set, and you will have B as part of this set. So these are types of some of important subsets of the real numbers. They play important role here. And as far as when we compare set of real number geometrically, we look at geometrically, you know that geometrically this set of real number is mapped, is in one-to-one correspondence with this line, and that's why this line is sometimes known as real line or number line. And if you mark a certain point on this line and call it 0, then at equidistance you keep 1. Here you will have -1, and you will have 2, you will have 3, so on, -2, -3. Then there is one-to-one correspondence between these points of this line and the elements of this set X, R, set of real numbers. That is, for every real number X, there is a point on the real line, and for every point on the real line, there is a real number in R. In this way, it is a one-to-one correspondence. One-to-one correspondence between the points of R and D, but with the points of this line R and this line and points of elements of R. So then if keeping this correspondence in mind, then we see that what is an interval. If you have, for example, you have 2 and 3, that means you will have all those real numbers lying between 2 and 3. अब किस you will have this interval will include every real number between 2 and 3, and that corresponds on the real line to the segment from with endpoint 2 and another endpoint it's 3, this segment. But it is an open segment because 2 and 3 is not included. When it's a closed interval, then it's a closed segment from 2 and 3. So this is a this sometimes this interval is also known as a segment, and if it is open interval, then you can call it as an open segment, and if it is closed interval, you may call it as closed segment, depending upon whether the interval is open or closed. In closed segment, that's a line segment that includes its endpoints, and in case of open interval, it's a segment which do not include its endpoints. Okay. Now, after defining this interval, let's come to the absolute function. This absolute function is a real valued function, and absolute value of any real number, which is the value given to any real number by the absolute value function, is denoted by mod of x, and let me write for each real number x, mod of x, read as mod of x, is defined as, this is another real number, it will be x if x is bigger than or equal to 0, and it will be minus x if x is less than or equal to 0. Then this is known as absolute value of x, and this absolute value is a function. Actually, if you look at this absolute value is a function from set of real numbers to set of real numbers. And if you want to calculate absolute value of any real number, for example, if you want to calculate absolute value of 2, by definition, since 2 is a positive number, it will be 2. At the same time, if you want to calculate the minus 1's absolute value, by definition, since minus 1 is a negative number, it has to be minus of minus 1, it is equal to 1. So one thing is clear here, that you can see by definition that for any real number, the mod of its absolute value is always greater than or equal to 0. It doesn't take the negative values. Why? Because when x is positive, it's already positive. When x is negative, you multiply it by minus 1, and minus multiplying negative number with minus it makes this number non-negative number. So one thing is clear, that this is greater than or equal to 0. So now if you look at this, what is this thing? Let us look at on the number line, and this is 0, and let us suppose you have x here, and the distance from 0 to x is actually here the x, but when you have this as a negative number minus x here, and still the distance from 0 to x is what is the distance? It's not minus x. Minus x is a negative number. If the distance from 0 to, for example, instead of let me take it 2. So the distance from 0, distance 2 is 2, and I can write this 2, since 2 is a positive number, I can write it as a modulus of 2. And similarly, the distance from 0 to minus 2, this distance is always a positive quantity, it cannot be negative, minus 2. How many units is this? Is also 2, and this 2 can be written as minus of mod absolute value of negative minus 2. And this way, if you were to look at this real line, this mod of x is nothing but it's the distance of the point x on real line from the origin 0. This is the distance. So geometrically, mod of x is nothing but it is the distance of the real number x from the 0. And likewise, if you have two real numbers, x and y be two real numbers, then x minus y is also a real number. We already know this thing, and so its modulus can be defined. And then x minus y uh, is defined, and the absolute value of x minus y is nothing but it is can be viewed as a distance from x to y. Distance from x to y. You have this here, you have x here, you have y here, and this distance is denoted by mod of x minus y. But distance has certain properties, and since distance is not a vector quantity, since distance doesn't depend, since distance does not depend on the direction, that means the distance from x to y is same as the distance from y to x. Hence, the distance from x to y, which is mod of x minus y, is going to be same as the distance from y to x. So this property is also known as symmetry. This modulus function has this symmetry property that modulus of x minus y is equal to modulus of y minus x. And another thing that you might observe about the distance function is that since distance is 0, when the distance between 2 points is 0. Sorry, since the distance between 2 points is 0 only when the points coincide. When the points are same. That is what it says, that is the distance between x minus y is 0 if and only if x is equal to y. And what it also implies, it also implies that the distance is positive. When distance between two numbers is positive, then surely the numbers are not same. They are going to be different numbers, because for same numbers the distance is always 0. So these are some of the properties of the distance function, or the absolute function that you have. And there is another property, triangle inequality. I will go to triangle inequality later on, but first let me give you a formula to compute this modulus of x. Another formula, an alternate formula. I will put it as an exercise. It says that for any real number, mod of x can be evaluated as maximum of x minus x. Look at, so what is the definition? What is the definition of mod of x? Mod of x is equal to x if x is non-negative, and it is minus of x if x is less than or equal to is less than 0. So now look at this thing. Now you have the two possibilities, and let us take a real number, and you have two choices. You have two possibilities. One, when x is greater than or equal to 0, then maximum of x and minus x, since x is a positive number, so minus of x is going to be negative. So maximum of positive and a negative is always a positive, that is x. And also what is the modulus of x now? Modulus of x is also now x. So in that case you have the equality between these two numbers, mod of x and max of x and minus x. And in the other case, when you have x as negative number, when you have x as a negative number, then you know that mod of x has to be by definition minus of x, and minus of x then is a positive number. Then it is a positive number, and so what should be the maximum of x minus x? Again you have a case of positive and a negative, and now x is a negative and minus x is a positive, so maximum has to be minus x. And in this case also mod of x is equal to max of x and minus x. Okay, so this is also another way to look at this modulus of a real number. And the another thing that is important to tell you, that you can try, is this exercise, that modulus of x and its negative number are same. X and its negative number is same. And other properties that you should go is when you have a product of two real numbers and you want to find the modulus of the two real numbers, that comes out to be modulus of x into modulus of y. You have to verify these properties. And the final thing where you have a relation, this is the relation of multiplication with this modulus function. Now we look at the relation of another binary operation, a relation of addition with this modulus function. And this relation is described by an equality, which inequality is commonly known as triangles inequality. This is known as triangles inequality. This triangles inequality states that when you have two real numbers and you find their sum and you take their modulus, then we want to see what is the relation of the sum of the modulus of the x and y, and you have this less than or equal. Why this is known as a triangles inequality? It is known as a triangles inequality because if you look at the triangle, any triangle, there is a property of the triangle that the sum of the two sides of a triangle is always bigger than the length of the third side of the triangle. So when you have this x plus y, this is the bigger side of the triangle, and let this be mod x and mod y, then the sum of the other two sides is always going to be bigger than the length of the bigger side, that is mod x plus y. But how we are going to prove it? And there is another very important property of the modulus function, that is that square of a modulus is always the square of the number. This is very verifiable, and it is quite clear from the definition. So you have these things, so therefore I'm going to use this as x plus y mod square is equal to x plus y square, and I can write it as x square plus y square plus 2xy expanding, and this x plus y square. And now since x square is equal to mod x square, I can replace it by mod x square, and y square is equal to mod of y square. And now you have 2xy. Let me call this equation something, and let me refer to another inequality, that is described by this modulus function that you need to have that. Look at the definition. Since mod of x is equal to maximum of x minus x, so it implies that x is always less than equal to maximum of x minus x. The number is always going to be less than or equal to its modulus. So I'm going to use this in this previous exercise, and in previous exercise we have mod of we have xy, and then using this exercise I will have xy less than or equal to mod of x. So using this in this previous equation, which I have named as star, we get what we get this mod of x plus y square is less than or equal to mod x square plus mod y square plus 2 times mod xy. Again, using the property that mod of xy is equal to product of the mod of x and y, it is equal to mod x square plus mod y square plus 2 times mod x into mod y. And now it is a expansion of mod x plus mod y whole square. This is equal to this thing. And now what you have this thing, mod x plus y square is less than or equal to mod x plus mod y square. And now you take, since your square is of positive numbers, non-negative numbers, you take the positive square root on both sides. What you will get x plus y mod is less than or equal to mod x plus mod y. This is the required triangles inequality. Mod in the beginning I gave you the definition of an interval, open interval or closed interval. And the definition of an open interval is you have this AB, but what I'm going to write the definition, whatever. Let me take an open interval, and this is set up all those real numbers which lie between, strictly lie between A and B. Now this is a A, this is B. This is a segment. It has some center here, and center is obviously, if you look at the center, it is A plus B1 2. Let this center be something x0. And what is the center? What is the definition of a center? The distance from center to A is equal to the distance of center to B. That means if I take any element here x in this interval AB, then, and let this distance be what you say, that this distance from center to A be some number r, then the distance of this any element, obviously we are taking x, so this x lies somewhere anywhere. Let this x be somewhere here, x. So then the distance of x from x0, this is the center, and this has to be less than r. If it is open interval, it has to be less than r. So then this implies that whenever you have in general, whenever I have x minus x0 less than or equal to or less than r, if and only if x belongs to this set x0 minus r and x0 plus r. What is this x0 plus r here? This x0 plus r, x0 minus r is actually A, and this x0 plus r is B. This can be verified here because the distance, and you have this x0 as A plus B upon 2, and the distance here, you can compute this distance here is in case of this, if you want to compute this distance, look at this line, and the distance from x0 to A is A plus B upon 2 minus A, and this distance, this is r. And similarly, on right hand side, the distance from B is B minus A plus B upon 2. And both these are the equalities. So this is the relation between absolute value and interval. Intervals can be interpreted through absolute value also. Sometimes we write that x in some interval x minus x naught x yeah r minus x, sorry, I'm writing x is in x naught minus r and x naught plus r. This is a better way to write the interval. This r stands for the distance from the center up to the end points, and this implies this is true whenever the distance of x from x naught is less than r. When it is a closed interval, you have less than r equal to instead of less than. Yeah, this is our thing, and I will stop here by giving a problem to you, which states that let a be real numbers such that a plus epsilon. No, I'm not taking and the b not. I'm taking any real number such that a plus epsilon is greater than b. Yeah, b also. A plus epsilon is greater than b for all epsilon greater than 0. Then prove that a is equal to b. This is the number, and I am going to hint you a very thing, that if epsilon is greater than or equal to 0, and if t is greater than or equal to 0 and t is greater than 0, then no, okay, it is not difficult thing to you just have to begin with that. Suppose that a not equal to b, then you have to choose a particular epsilon, and then you will have to choose a particular epsilon, and particular choice of that epsilon will you give a contradiction to the fact that a plus epsilon is strictly greater than b. Okay, this is a very important exercise. Then I stop here.